Episode of Brainwave Academy. Now today we're going to be discussing a few examples on AP and GP, technical ones, before we move into the sum of AP and GP. Now you can be asked a question like, can you be able to find the value of x in an expression like if 1 all over x, comma, you have 1 all over 2, then you have 1 all over 3. Now, if these are consecutive terms or successive terms of an AP, these are successive terms of an AP, right? AP. Now, you can be asked to find the value of x, or you can be asked to prove that 2 minus x over x minus 3 is the same thing as 2 all over 3. Now, if you ask this kind of question, it's technical but it's simple. All you need to do is to use the idea of common difference, right? Which means 1 over x minus 1 over 2 should be the same thing as 1 over 3, then minus 1 all over x, right? Since these terms are successive, so this minus this should be the same thing as this minus this. So here you can look for the LCM, which is 2x. When x goes into 2x, we're left with 2 multiplied by 1, you get 2. When 2 goes into here, you're left with x minus 1, multiplied by minus 1 is x. Similarly here, the LCM here should be 3x, right? So when 3 goes into 3x, we are left with x. Why if x goes into 3x, we are left with 3 multiplied by 1, which is 3. So it's very simple. To clear this fraction, all you need to do is to multiply both sides by 2 initially. If you multiply here by 2x, you do the same to this part of the equation by 2x. So I think this and this will go, this also, this x that is here can go with this x that is here. So here we're left with these 2, while here we're just left with 2 minus x is equivalent to x minus 3. This is all upon 2. 3 multiplied by what? 2. So we can do the same thing. We can multiply this side of the equation by 1 all over x minus 3. What are we trying to do? We are trying to prove this. So similarly, we're going to multiply here by 1 all over x minus 3. So this can go with this. Similarly, then we are left with what here now? We are left with 2x. Rather, we are left with 2 minus x upon x minus 3. This should be equal to what is left here. We are left with 2 all over 3. Now, right, this is very, very crucial, and then you have been able to prove this. Likewise, you can be asked to find the value of x here. So all you need to do, if you're asked to find the value of x here, you can cross multiply this, cross multiply, you have 3 multiplied by 2 is 6, minus 3 multiplied by x is 3x. Then the other side, you're going to have 2x, then you have minus 6, right? So if this goes to this side, we have 6 plus 6. While this goes to the other side of the equation, we now have 2x plus what? 3x. Now it's simple. This is now 12 is equal to, what do you get here? 5x. So if you divide both sides by 5, you get x is equal to what? 12 upon 5. So it's pretty simple. Now quickly, with that being said, we are going to go straight into what the sum of AP is. Now when you talk about sum of AP, you're trying to sum all the terms like you see here. We are going to add all these series together. Then we have 1 on the left hand side, we just get 2, which is just the same. Why this, we get a series of them all. So on the right hand side, we are going to get n into a plus l, where a is the first term and l is the last term. So if you divide both sides by these two here, you're going to get this formula that for every Sn, we have found that the sum of all the series is just Sn, right, which is just 1 over 2 n into a plus l. Now you can see it written as s of n, which is equal to n all over 2 into a plus l. Now l here is the last term, right? The last term, while a here is the what? Is the first term. Good. So similarly, you can have this formula. You know the n term of an AP is just a, right, plus n minus 1 d. We all know this from what we have initially. We all know this. So if you substitute the value of n, the last term, if you substitute it here, you're going to get this. So upon expansion, a plus a, you get 2a plus n minus 1d, and this becomes the formula for the sum of an AP, right? This is the formula, this is also the formula. It's the same thing here, provided you have the first term and the last term. While here, if you don't have the last term but you have the common difference, you know the first term, you can get L using the formula, which is this, and then you can substitute it here and continue with your arithmetics. Now similarly, we have, for instance, we have this: find the sum of the first 50 terms of this sequence. Find the sum of the first 50 terms of this sequence. Now you can see the first term here, 1 3 5 7 9, continuously. We have the sequence is 1, we have the sequence is 1 3 7 9 continuously. I think these are odd numbers, so it's very simple. What are we supposed to do? The common difference is 2. 3 minus 1 is 2. 7 is, we're supposed to get 5. 5 is supposed to be there. We omitted 5, so we're supposed to have 5 over here, then continuously. Then you see the first term is 2, which is the first term here is 2, which is here. We are looking for the 50th term, right? The question says find the 50th term. So our n here is 50. So we have n is equal to 50, 50. We have 2. We have a. A here is 1. N here is 50 minus 1. Then common difference is 2. Anybody can do this. You can do this. 50 minus 1 is 49. Multiplied by 2 is 98. 2 multiplied by 1 is 2. Add them together, you get 100. Multiplied by 25, you get this. Very good. Now you see, find the sum of this series. Now see, series, we don't need to use any concept of AP that we know initially. We have the first term, we have the last term, we also have we can find anything we want looking for. We have the last term is this, the first term is this. We have know the common difference, 6 minus 3.5, or 8.5 minus 6, we get 2.5, which is here, right? So you can evaluate this. You have 1 here, right? So if you take it to the other side, is 101 minus 1. Then also you have 1 here. You take it to the other side, you now have 101 minus 1 is equal to n minus 1, all multiplied by what? 2.5. So you have evaluated this part. So you can likewise take this part to divide 101. So you have, I can divide both sides by 2.5. So here I'm going to have, let's get this done. We're going to have, here I'm going to have 100 upon 2.5 is going to give me n minus 1. I think so. We're going to get, if you divide this, you're going to get 40 equal to n minus 1. So you take this to the other side. That's how you got n is equal to 45. I think this is pretty cool and simple. So that is that about sum of AP. For instance, another example here, an arithmetic progression has 3 as its first term. That means our A is equal to 3, right? Then the sum of the first 8 term is twice the sum of the 5th term. Find the common difference. Technical, but simple, right? We have this. The first paragraph, the first sentence rather, tells us that S8 is equal to 1 over 2/8 into 6 plus 7D, right? And that's if you try to. The second one tells us that 1 over 2/5 multiplied by 5 equals to 6 plus 4D. That is what we have. But recall that they now say that S8 is twice of S5. So all we need to do is just put S8 here, but we multiply S5 times 2. S5 is all what we have here. Then you find the common difference. It's simple and short. So here, find the first term. Okay, this now we have the first term, we have the common difference. Then this is pretty straightforward. You can use the formula Sn. It's equal to 1 over 2. N all over 2 multiplied by 2 into 2a plus n minus 1d, and then you get this. Now let's see if we can just work with some. What do you have here? You have a here. A here is equal to 4. The common difference here is minus 3 minus 4. Minus 3 minus 4 is going to get minus 7, right? So you're going to get minus 7. That's the common difference. And find the sum, 28. So you're looking for S of 23, right? So it's very straightforward. It's just straightforward. You come back, look at your formula here. N all over 2 multiplied by 2a plus n minus 1d. You're looking for 23, so you substitute and evaluate. This is just straightforward. Very straightforward. You don't have the last term. Here you're given the first term, you're given the common difference. Find this. Is just straightforward. Now quickly, in this same video, let's talk about AP. Let's talk about GP, which is the next subtopic in progression when you're talking about sequence and series. Now, what is a GP? Now, the difference between the GP and the AP is that in the AP you are adding. Now, in GP you'll be multiplying. Now, we shall now move on to the next type of sequence that we want to employ and explore. You have this sequence 2, 6, 18, 4, 54. Now, each term is 3 times the previous term. If you look at it, the power, right? This is multiplied by 3, you get 6. 6 multiplied by 3, you get 18. 18 multiplied by 3, you get 54. And this sequence also, you have 1 minus 2, 4. Now, each time you multiply the previous one by negative 2, you're going to get the next one. See, minus 2 multiplied by 1 is minus 2. Minus 2 multiplied by 2 is 4. 4 multiplied by minus 2 is minus 8. The next one will be minus 8 multiplied by minus 2. This will give you 16. Right, so if I'm to continue this sequence, I'm going to get 16. Right, then multiply by minus 2, I'm going to get minus 32. Multiply by minus 2, I'm going to get positive 64. Right, multiply by minus 2, then you're going to get it continuously like that. Now, if you look at it, instead of adding, we are multiplying by the by that singular term. So that term, we call it common ratio. In AP, it is common difference, while in GP is now common ratio. So your first term, like you see, we shall let R be this common ratio. So in so many textbooks, you're going to be seeing A, which is the first one. The second will be AR. The next one is AR square, because at every point in time you are multiplying by that particular common ratio. So in that case, so n can be calculated using this particular formula, where the n minus 1 is always less than the position we are talking about, right? So if I have, let's say the first term is A and the common ratio is 3, then it's very simple. I can get that sequence like 2, Then the next one is going to be what? 2 multiplied by 3. The next one, 2 multiplied by 3 raised to power 2. The next one will be 2 multiplied by 3 raised to power 3, and so on and so forth. There's a key point here for us. A geometric progression, GP, is a sequence where each new term after the first term is obtained by just multiplying the preceding term by a constant of r. This is usually called the common ratio. If the first term is a, then the progression is just this way, which is very simple. So for instance, this is like an exercise. Write down the first 5 terms of the geometric progression which had its first term as 1. So let's see if we can do this. The first term is 1, so we have a is equal to 1, and the common ratio is 1 over 2. So r is equal to 1 all over 2. So write down the first 5 terms. For the first one, we're going to have a multiplied by r, which is going to be 1 multiplied by 1 all over 2. This is just 1 all over 2. The second one is going to be a multiplied by r squared, which is just 1 multiplied by 1 all over 2 all squared. This is going to give us 1 multiplied by 1 all over 4, right? So the next one is going to be a multiplied by r raised to power 3. Then it's going to be the same way like that continuously. Now this one says find the 10th and 20th term of GP with the first term 3 and the common ratio of 2, right? Right? So this is also straightforward. You have first term a is equal to 3, common ratio is 2. We're looking for the 10th, and it's always a raised to power r and minus 1. So what are you going to get? You're going to get 3, then 2 raised to power 10 minus 1. So this is just 3 multiplied by 2 raised to power 9, which is just straightforward. Anybody can do this. Now the sum of GP. What if you want to sum them up? Now it's very tricky. You see, the sum is just a plus ar plus ar squared, because these are the terms, right? So if you decide to sum them, this is called an arithmetic series, geometric series. Now the trick here is to find the sum, is to multiply by r and then subtract them. You find this, you multiply by r and subtract. Now if you look at it, every other terms we cancel out, right? A will go down, but r is going to cancel out. They're going to cancel out, so you're left with a minus ar raised to power n. So if you decide to factor out Sn outside, if you decide to factor out Xn, you're going to get Xn into 1 minus r. What will be left here will be a factored 1 minus r raised to power n. That's what you have here. Good. So we divide both sides by 1 minus r, you're going to get this. But there's a restriction, right? The restriction is that your r here cannot be equal to 1. So this equation here is valid if and only if this equation is valid, right? If and only if you have the fact that that equation holds if r is never going to be equal to 1. So this is valid for that particular reason. So key point, this now become our formula for the sum of GP, right? So if you want to sum these, guys, right, we have, for this series, we have a is equal to 2, r is equal to 3, so definitely r is not equal to 0, r is not equal to 1 rather, so our denominator cannot be 0. Then we apply the formula. Then this is straightforward, anybody can do this, right? You have a here is 2, right? You have a here is 2, this is it. You have 1, this is 3, this is the common ratio, n is 6. right? 1 minus 3, that's straightforward. So we also have all these when r becomes 1, the denominator is no longer valid. Then we can talk about the convergence of a sequence. Now, if you consider the geometric progression 1 all over 2, 1 all over 4, 1 all over 16 continuously, then we can say that it follows a pattern, right? There's a pattern to it. So if we can calculate the sum, we get this. It's following a pattern. Can you see? And here it seems to the pattern because we have 1 is equal to this, then 3 all over this is the same thing as this, then 7 all over 4 is the same thing as 2 minus. So if you follow this pattern, you can say in each case we subtract the quantity 2 from it, and we take successive sum. The quantity gets smaller. The quantity is getting smaller. Quantity is getting smaller. So if we're able to add to infinity many times, then the outright will be 2, or somehow very close to 2, right? So let us see if you have this formula in place. Then we want to examine this formula in the case of a particular example if r is equal to half. Now the formula contains the term r. So 1 minus 1 is less than r is less than 1. This term will get closer and closer to 0, and the terms is going to go closer and closer to 0. So if minus 1 is less than r, we can say that the sum to infinity of a geometric series is this, right? Because this term goes closer and closer to 0, right? So where we omitted the term Rn, we say that this is the limit of the sum of n. So you take this when you take n to a very large number, this exponential will disappear, because as it's getting larger, it's getting smaller. So that's the concept of sum to infinity. When it says you sum it to infinity, you just say a all over 1 minus r, where r is always in between minus 1 and 1. If r is greater than, then you will have challenges to answer that. So feel free to comment in this comment section if you have any question on AP and GP. If you want to get this document, subscribe and send me a message. See you in the next video. Thanks for listening.